Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence as well as the feedback regarding the quality of audio as well as video. If it is perfect, just write perfect over the live chat and then we are ready to go. Anyways, the agenda behind the series which we have been running so far must be clear to all of us, that we are taking the reference of the questions from the engineering mathematics which have come in year of 2021 from all of these 7 branches, and taking the references of those questions we are building the concept for GATE 2022 specifically for the engineering mathematics. And one thing must be known till this date, yes, all of the questions which have come here and there, they have segregated in terms of their respective topics. So the topic which we were studying in the last video, probably you guys would be able to understand. I have taken few number of questions which were based on the concept of maxima and minima. And even one problem which I have taken in the last class, that was based on the concept of mean value theorem. Yes. Anyways, without going to delay much, let me straight away hop into the remaining questions. And probably I would not be taking the complete 1 hour in today's video. Probably we are going to spend somewhere 30 minutes or more than 30 minutes. So only 3 questions I have planned to take in today's video. So is it perfect or not? The quality of audio and video, if it is perfect, just write perfect over the live chat. So at least I'll have the fair idea. So let me go back into the PDF. Now, if you'll recall, what are the questions were taken? What were the questions were taken in last video? In last video, the first question which I have taken was the problem related to the Lagrange's mean value theorem, where we wanted to get the value of C or the value of X at which the slope of the straight line which is connecting 1 and 3, and at the same time the instantaneous slope over the functions has the same slope that we have seen in the last class. And at the same time, in the same sequence, we have taken the next problem where the cos of x has to be approximated around x is equals to 0 using the Taylor series expansion, and it has been approximated till its 4th degree of polynomial. That means it's a type of biquadratic polynomial, and for that you need to find the value of a, b, c as well as d. So the best most answer which we got in the last video, obviously the answer was A. Similarly, in the same sequence, we took the next question where we had a quadratic polynomial f of x is equals to minus x square plus of 10x plus of 100. I wanted to get its minimum value over a closed interval of 5, 10. Anyways, I smashed this problem out with the help of 2 different methodology. The first methodology, I drew this curve which was a lower facing parabola, and once we got to know it was a lower facing parabola where the stationary point has been formed at x is equals to 5, I got to know the minimal most value within the closed interval of 5, 10 would appear at x is equals to of 10 itself. So straight away you will plug the value of x is equals to 10 and you will get the minimum most value within the closed interval of 5, 10, and that is nothing but the 100, which we have calculated in the last video. Not only that, in the same sequence, I took the second methodology. What it was? It was a predefined methodology which we apply over the concept of maxima and minima. At very beginning, I took its first derivative. Its first derivative was compared with 0. Its first derivative was minus of 2 of x plus of 10, and when compared with the 0, the result which we found was simply equals to of 5. And now double derivative test has to be conducted over the same stationary point just to know whether it was a point of maxima or minima. Once we calculated the double derivative at x is equals to 5, we got to know the value was found to be negative. That means here the maxima was being found. So obviously with that methodology we got to know 5 is the point of maxima, and hence in between the closed interval of 5, 10 the minimal most value would appear at x is equals to 10, and from there also if I feed x is equals to 10 over this quadratic equation or in this quadratic polynomial, the answer which we got, the answer is precisely 100. Yes, precisely 100. So till this moment of point, each and everything must be clear to all of us. Now here goes the next question, or you can say the first question of the day. Anyways, for the better understanding what I would be doing over here, let me bring this problem into the working board. Here goes this problem into the working board. Yes. It is the 8th question in sequence and the first question of the day. Anyways, let me first discuss about the character of this question. This problem have come in gate instrumentation in recent year, which is in year of 2021. That's fine. Let's see what exactly this problem states. Let f of x be a real valued function such that, what does that mean by the f of x be a real valued function? That means for all possible value of x, f of x would always result a real value. I have seen many of the times the student used to have doubt over this statement. Like if you have a problem, or if you have a function f of x is equals to of, let's take root over of x minus 1, root over of x minus 1. My dear friend, if the value of x is greater than equals to of 0, in that case the f of x would be real valued, if the x goes lower than 1 by default, the result what we get, it's gonna be complex in nature. That means this sort of function has been ruled out. You had a function which are free from any fractional power. Otherwise, if you have any fractional power, definitely you would have the problem. Like this. Yes, be a real valued function such that f dash x 0 is 0 for some value of x naught within the open interval of 0, 1. Yes, and f double dash x 0 is greater than 0 for all value within the open interval of 0, 1, then f of x has. So I would request to each one of you, try to read this problem carefully and try to decode what would be the most answer for this given problem. It is a sort of theoretical and conceptual problem. Otherwise, the problem which used to be framed from the concept of maxima and minima, they used to be a numerical sort of problem. But here, rather designing the problem into the numerical domain, they have designed this problem into the theoretical domain. So until and unless you are not much thorough about the concept of maxima and minima, probably you are going to stuck over here. How many different options were given? The 4 different options were given. One local maximum in obviously open interval of 0, 1. It could be anywhere in between 0, 1, excluding 0 and exclusive 1. 2 distinct local minimum in between open interval of 0, 1. Obviously, it can be anywhere in between 0, 1, excluding 0 and excluding 1. Similarly, option C, which has been attached along with this problem, local minimum in open interval of 0, 1. That means it can be anywhere in between 0, 1, excluding 0 and 1, exactly one local minimum. Tell me what would be the most answer. So still let me write few more number of datas which are supplied along with this problem. Which has been supplied along with this problem. See, within the open interval of 0, 1. So my complete analysis has to be made over an open interval of 0, 1. Either it is maximum, either it is minimum, either it is distinct 2 number of minimum, either it's a distinct 2 number of maximum. So one thing is quite sure, the domain of study for at least this problem, domain of study, at least for this problem, has been the open interval of 0, 1. That means the domain of study has been in between 0, 1, or x is falling in between 0, 1, excluding 0 and excluding 1. This has also been given along with this problem. Now. The next information which has been supplied along with this problem, such that f dash x naught is equal to 0 for x naught belongs to 0, 1, and here it has been clearly given real valued function such that f dash x naught is equal to 0 for sum. What does that mean by the sum? That means it can be 1, it can be 2, it can be 3. That means in between 0, 1, you have maybe 1 number of x naught, or 2 number of x naught, or 3 number of x naught, which satisfies this requirement. Could you understand what this problem is wanting you to focus on? This problem wanting you to focus on the sum. No, sum is making this problem more miserable. That means you can have one value of x naught in between 0, 1. You can have 2 values of x naught in between 0, 1. You can have 3 values of x naught in between 0, 1, where it has been clearly given where the first derivative of the function becomes 0. So let me write that also. Where x naught belongs to the open interval of 0, 1, and it has been clearly written. You can have some values of x naught. That means you can have one possibility, you can have two possibility, you can have three possibilities over the open interval of 0, 1. Over the open interval of 0, 1. My dear friends, what it indicates? The first derivative of the function at x naught becomes 0. That means the x naught has been the point of stationary. Yes, so at least one important conclusion we can retrieve out of this. How many number of x naught is coming in between 0, 1? That is secondary matter, but yes, the x naught would be a point of stationary point. Yes, the point of stationary point, and even the stationary point can be bifurcated in a part of extrema. Even the extrema can be further bifurcated in terms of maxima and minima, or it could be a saddle point. Even the saddle point could have been bifurcated in the two part, decreasing saddle point or increasing saddle point. Just a minute. Decreasing saddle point or increasing saddle point. Yes, till this point each and everything must be clear to all of us. Now one more important thing has been given, and f double dash x naught is greater than 0 for all x belongs to the open interval of 0, 1. What does it mean of it? My dear friends, if it says double derivative of the function at x naught for all possible x naught is always been greater than 0. Anyways, first tell me, what does that mean by the f double dash x naught greater than 0? That means there has been the formation of minima. Yes, there has been the formation of minima. That's the first thing. Secondly, what it tries to say, for all possible values of x naught which belongs within the open interval of 0, 1, that means whatever the stationary point would be formed, they all would be minima. What I am saying, I would repeat once again. So far they have said the x naught would belong within the open interval of 0, 1, such that in some values of x naught would satisfy f dash x naught is equals to 0. That means all possible values of x naught would be the point of stationary. The point of stationary could have been figured it out or the bifurcated as the extrema. Even the extrema could have been figured it out in the two points, that's the maxima and minima, or even it could have been the saddle point. It could have been a saddle point. Agreeing? No? Till this point probably each and everything must be agreeing to all of us. So what is happening over here? Now at least till this point you will have several number of thoughts. Sir, how many number of points they could be? They could be 2, they could be 3, and they could be extrema, they could be saddle point. So how we exactly figure it out which is gonna be the best most answer? The second statement is going to unfold each and everything. F double dash x naught within the all possible value of x from 0 to 1 has been greater than 0. That means whatever the stationary point is going to occur in between 0 to 1, they all would be minima. Exactly, I do not know whether it's 1, whether it's 2, whether it's 3. My dear friends, I do not know how far you could understand the concept of maxima and minima. Two maximas cannot occur in adjacent. What I am saying? Two maximas cannot occur in adjacent. Could you understand what I am saying? So let me draw a curve for the better understanding. If you have taken a x-axis as well as y-axis, let me draw a curve over here. See, if you have drawn a minima, and if you had to draw the second minima, no, so all the way you had to increase the function, then decrease, and then further increase. What does that mean of it? That means the two minima point cannot come in adjacent. The minima would come after the maxima alone. Not only that, just try to understand this. If you have taken a saddle point, yes, again if you had to found a minima, again you all the way you had to make a maxima, then only again you can make the minima, That means within two minimas, even the saddle point can also not come. Could you understand what I am saying? So if you want, you can write somewhere the two maximas and two adjacent minimas cannot be there. two adjacent maximas or two adjacent minimas cannot be there. That means periodically maxima, minima, minima, maxima would come in practical. Practically maxima, minima, minima, maxima would come into practical. And now it has been clearly told, for all possible values of x naught within the open interval of 0, 1, f double dash x naught has been greater than 0. That means all possible values are minima. So how many number of possible values you will be having? Only one. Only one, because you are getting only and only one stationary point, or for all stationary point they have been minima. That means only one strict minima you would be having, and that is nothing but the option D. That is nothing but the option D. Could you understand what I am saying? Anyways, let me give few more amount of time for this problem. What I am saying, fx is being a real valued function, so obviously this sort of function has been ruled out. That's the first thing. F dash x dot was 0 for some value of x naught where the x naught belongs to 0, 1. Why the word sum has been taken? Because the x naught could be any value in between 0, 1. It could have been like 0.1, it could have been like 0.2, it could have been like 0.3. So that means we have got few number of stationary point within 0, 1. So now if we have got the few number of stationary points within the 0, 1, now it has been precisely asked over this problem how many number of maximas, how many number of minimas you would be having over 0, 1, and just they have given word sum to make you confuse. Because you yourself do not exactly know how many stationary point is being kept in. So what you did, you went into the second expression which was given along with this problem. But it was given the f double dash x naught is always greater than 0 for all possible values of 0, 1. That means all of these stationary points, now either whether we have got a 1 stationary point or the 2 stationary point or the 3 stationary point, whatever the stationary points we are getting in between 0 to 1, they all would be minima only, my dear friends. Now you yourself can see the two minimas cannot come together. If they are coming, definitely in between another maxima had to come, and it has been clearly given f double dash x naught would always be 0 for all possible values of 0, 1. So obviously you cannot form maxima within the range of 0, 1. So only one minima is possible within the 0, 1. So the best most answer is going to be option D. Best most option is going to be option D. No, you can't have this. You can't have this. You cannot say like this. You can't say like this. Like, sir, this is x is equals to 0, this is x is equals to 1. No, my dear friends, you can't say like this. So the best most answer is going to be option D. Till this point, each and everything must be clear to all of us. Now it's right time to move into the next question. And this was a question. This was a question. Just a minute. Yes. This was a question from two independent variable f of x, and here also we had to focus over its maxima as well as minima. Anyways, keep aside this problem and we'll smash this problem out. This problem has appeared in GATE Engineering Services Examination year of 2020. What the problem has been given, find the absolute maximum and minimum value of f of xy is equals to of 2 plus of 2x plus of 2y minus of x square minus of y square on triangular plate in the first quadrant bounded by the line x is equals to 0, y is equals to 0, y is equals to of 9 minus x. Anyways, for the better understanding what I would be doing, at very beginning let me start with the solution. First focus over the bounded area over the xy plane. So let me take the reference of the xy plane. Here goes the y axis, here comes the x axis. Here goes the y axis, here comes the y axis. Now it has been clearly given, you have got a bounded path which has been bounded by x is equals to 0. May I know what does that mean by the x is equals to 0? That's the y axis itself. Y is equals to 0, that's the x axis itself, and y is equals to of 9 minus x. Obviously it is a straight line having a slope is equals to minus 1, and it would be crossing y axis at 9. So end of the day you must be able to know this is the bounded region which they have been talking about. More precisely, this curve satisfies y is equals to of 9 minus of x. This curve satisfies y is equals to 0, and this curve satisfies x is equals to 0. And the function which has been given to you, it has been clearly given. We had got a function f of xy. What does that mean of it? That means the function f is a bivariate function. It has got two independent variables which starts from 2 goes to 2 of x, 2 of y minus of x square minus of y square. And as they have been talking about the maxima and minima which are getting involved with this, what would be your approach, my dear friends? we used to calculate few number of important coefficients which starts from p goes till t. Yes. So let me focus on that. P. How the p is being defined? It's a dou f divided by f dou x. Once you'll take its partial differentiation, it would simply be 2 becomes 0, 2x would lead to, and here it would become minus of 2x. Q. You will take the partial differentiation of f with respect to the y. So obviously this becomes 0, this becomes 0, this becomes 2, and this becomes minus of 2i. Here goes q. In the same sequence, we are going to take r. What does it mean by the r? The r is partial differentiation of f with respect to the x twice. So you can take the reference of p now, and now you can just differentiate once again with respect to the x. The result what we are having is simply going to be minus 2. The result what we are having is simply going to be minus 2. Yes. Here goes s. Here goes s. Many of the times I have seen the student used to have doubt over this point, but no. Here dou square f divided by dou x dou y comes. So either you can take the reference of p, you can differentiate with the y, you can take the reference of q, you can differentiate with the x. You do either of the way, the result what we get is simply going to be 0. Simply going to be 0. Once we are done with this, obviously it's right time to discuss about the t. Here it's going to be dou square f, and here goes the partial differentiation of f with respect to the y twice. Obviously once has been taken place with respect to the y. So it's right time to take its differentiation with respect to the y once again, minus of 2. At very beginning, what we will try to get? We will try to get the stationary point. What does that mean by the stationary point? The stationary point at which the slope over the 3D structure becomes 0. How do we do that? Obviously, we would be comparing this with 0. We would be comparing this with 0. And once we'll be comparing, it becomes a linear equation with one variable. Obviously, the value of x can be easily calculated. Minus 2, minus goes out. The value of x which we got to know is nothing but x is equals to 1. And here it is nothing but y is equals to 1. Y is equals to 1. So till this point, each and everything must be clear to all of us. Must be clear to all of us. Agreed? Now, I should understand whether the x is equals to 1 and y is equals to 1 is coming in between this structure or not. Yes, you can see by yourself. My dear friends, x is equals to 1. If you go beyond x is equals to 0, obviously the value of x would keep increasing, and you can see very well the x has been 1, that is greater than 0. Similarly, if you will take the reference of y is equals to 1, it has been above y is equals to 0. So obviously it is supposed to come within this closed range, but still you had to take the reference of y is equals to 9 minus x. Whether it is getting satisfied or not. How will you know about it? So simply put this value. And you will get the value out of this. My dear friends, this is the range now. This is the range. That means the value of y has to be lesser than the value of 9 minus x. And you can see very well, if you will keep y is equal to 1, 1 is lesser than 9 minus 1, that is nothing but 8. That means yes, 1 comma 1 or x is equals to 1 and y comma 1 has been somewhere here, yes, and it has been within this closed triangle. So I have seen many of the times, if this many data are being supplied along with the problem, many of the times the student get stuck, but you need not to worry anywhere. X is equals to 1, obviously it has been towards this side, y is equals to 1 has been towards this side, but that 1 comma 1 should not go beyond this straight line, it has to be in between. So now how will you check? This straight line can be written in the first quadrant as y lesser than 9 minus x. Why? Because if you take the reference of this straight line stands for y is equals to 9 minus x, and now if you're coming down, that means the y has been keep decreasing, obviously taking the reference of 9 minus x. Here goes like this, and now if you want to keep this value into the first quadrant, because the enclosement has been taken only for the first quadrant, for that the x has to be greater than equals to 0 and y has to be greater than equals to 0. Now you yourself can feed the value of x over here. X has been positive, and the result what we get is also positive and satisfying the requirement. That means 1 comma 1 is part of enclosed surface. Till this point, each and everything must be clear to all of us. Anyways, we'll move forward. Once we are done with the stationary point, we'll go with the RT minus of S square test. Obviously, this test would be conducted at the stationary point. What is the R over here? The R is minus 2, that is a 4, and S is simply 0. So here it goes. minus 2, minus 2, and the worth is simply 4. See, the value is not that important, its polarity is more important. My dear friends, the RT minus of S square test can land into the three different situations. If the RT minus of S square has led a positive outcome, has led a negative outcome, and has led neither negative nor positive. If RT minus of S square leads positive value, that means the point of stationary, it is a point of extrema. That's a point of extrema. Could be maximum, minima. If it is led minus, that means neither extrema. Sorry, it is not the point of extrema. It's not the point of extrema. Agreed what I am saying? And if the value has been found 0, whether it can't be said as a positive or negative, then further investigation is required. Further investigation is required. Yes. Here goes the further investigation is required. Till this moment of point, each and everything must be clear to all of us. So what I would be doing over here, again, if I calculate RT minus of S square, we got to know the worth has been positive. So obviously we have been landing up to this situation. That means the point of stationary would be the point of extrema. Now the next thing comes whether it would be a type of maxima or minima. Easily with the help of another test we can perform the outcome. Now what I would do, I would calculate the value of R over the stationary point. If it is positive, it can be negative. If the value of R has been found to be positive, keep in mind the point of stationary would be a point of minima, as it has been for one variable, and similarly otherwise it would be point of maxima. Agreed? What was the worth of R? Most of the time what happens, for the higher degree, even the R used to be the function of X and Y, and I used to feed the value of X as Y as a stationary point. But here, as the degree of polynomial is such a small, the value of R has been straight away found to be minus 2. What does that mean of it? That means it is found in this segment. So whatever the stationary point have been taken place now, that is a point of maxima. And where it has been taken place? It has been taken place at 1, 1, and it's a point of maxima, and obviously coming within the closed surface which we have been taking for. So it has been asked, find the absolute maximum and minimum value of this. So obviously the minima has been ruled out. You have to just focus over the maxima. How will you get the maximum value of f of x comma y? Obviously by feeding x is equals to 1 and y is equals to 1. Let me do that. So what I would be doing, I would be feeding x is equals to 1 and y is equals to 1, and whatever the result what we get now, that would be done. So here it becomes 2 plus of 2 plus of 2 minus of 1 minus of 1. So here it goes like this. So the best most result what we get now is simply going to be 4. So the maximum worth of this bivariate function is 4. So till this point each and everything must be clear to all of us. Yes. Let me go back. So the two number of questions I have taken. The first question was a classical problem of maxima and minima, and just by giving the word sum they wanted to play with you. So one thing must be there in your mind, for all possible values of x in between 0 to 1, if f double dash x naught is greater than 0, that means all possible stationary points could be only and only minima. But as per the concept, or as per the conceptual understanding of the maxima and minima, two minimas cannot fall in adjacent. There must be one minima, then maxima, then only minima. And f double dash x naught greater than 0 ensures there cannot be any maxima at all. What does that mean of it? Only one minima you have. The best most answer was D. In the same sequence, the 10th question, the problem was a bit different. How many number of independent variables were getting involved? The two number of independent variables were getting involved, and they were asking to find the maximum as well as minimum value. So within this range, I got to know the stationary point 1, 1 is falling, and 1, 1 has been the point of maxima. So just by feeding x is equals to 1 and y is equals to 1, I got to know the maximum value of f of x comma y. Yes, my dear friends. A spurious problem was designed in GATE production engineering year of 2021, and you cannot expect this problem would come in future. The minimal value of the function f is defined by First time this sort of problem has been seen over the function have got the 3 number of independent variable. It has been precisely known by f within the bracket x comma y comma z, and even once you'll watch this function, then also you'll get to know the x, y as well as the z has been present over here. And now you had to find its minimal worst value. My dear friends, so far we were studying about the concept of maxima and minima, where only one independent variable was getting involved, or worst of the worst situation, 2 number of independent variables are getting involved. My dear friends, in practical, you can have a function where you have got the n number of independent variable, and even you can apply the concept of maxima and minima for that f of x comma y comma z comma w comma a comma b comma, yes, you can. But as far as the gate is concerned, they used to stuck only and only over the 2 type of function, 1 variable and 2 variable. But here it has been a 3 variable function. Agreed what I am saying? It has been a 3 variable function. Anyways, that is why I have solved the problem here itself. I will just give you a glimpse how this problem could have been solved. But yes, you need not worry, because none of the questions could have solved this problem. Yes. None of the student. See, at very beginning, what we focus on? We focus on the stationary point. What does that mean by the stationary point? The rate of change of the function with respect to the independent variable must stuck to 0. So obviously, I have taken the partial differentiation of f with respect to the x, which has been 2x minus of 4, compared with the 0. So the x was found to be 2. Similarly, the same process was formed over y. That means the partial differentiation of f has been taken place with respect to the y. Compared with the 0, the value of y was been minus 4. Similarly, with respect to the z has been 4. What does that mean of it? That means the 2 comma minus 4 comma 4 has been the point of stationary. So within the bracket we can write 2 comma minus 4 comma 4 is the point of stationary. And now if you have the 3 independent variables involved with this function, you also had to get the value of a, b, c, d. What used to be the value of a, b, c, d? That is clearly written over here. There is a partial differentiation of f with respect to the x twice, partial differentiation of f with respect to the y twice. Similarly goes c and f, g and as well as h. Agreed? Now here goes like, see, since a is greater than 0, and if you get the determinant of AHHB, the value was found to be greater than 0. That means the stationary point 1, 1 is a point of extrema. It's a point of extrema. Again, I am saying you need not to go into the detailed analysis of this problem, because if you want, I can solve this problem thoroughly, but probably it is not at all required for you guys. But still, this sort of problem do come in GATE examination, and each and every student should have one thing in your mind: this problem was meant for leaving. If you have spent 2 or 3 minutes over this problem, and end of the day, if you have left 1 or 2 questions from the topic which you were comfortable, that means you are in big loss. You need not to touch this problem. Yes. So it was known to me, yes, the point 1, 1 is gonna be the point of extrema. Now the next thing comes, would it be a maxima or would it be minima? For that I would take its determinant. The determinant was found greater than 0. What does that mean of it? That means the point 1, 1, 1, no, it was a point of minima as the value is greater than 0. It has been the same concept if you take function having 1 independent variable, 2 independent variable or 3 independent variable. The same concept goes with this. That means 1, 1 has been the minima over the complete range of x, y, z. So what I would do at last? 2 minus 4 and something it was there. Okay, it was 2 minus 4 and 4, sorry. There was a mistake. It was not 1, 1. So end of the day, if you are interested finding the minimal value of this function, obviously you would be feeding x is equals to of 2, you would be feeding y is equals to minus 4, and you will be feeding z is equals to 4, and you will get this answer. So the best most answer what you would be getting for this problem is simply gonna be 136. So till this moment, each and everything must be clear to all of us. Yes. Anyways, we will meet with the next topic in the next video. So I would request to each one of you, try to share this video to max of your colleagues, junior colleagues, senior colleagues. Yes, we are going to learn a lot. Okay, then I would say take care of yourself. Try to put maximum amount of effort for your GATE 2020 or the ISRO or the BRC examinations which are supposed to come afterwards? Okay then, bye bye, good night.